Hello everyone, welcome back to Everything Swift. Today we'll be tackling Leetcode question 680 titled Valid Palindrome 2. I did the first part of this question, Valid Palindrome 1, a couple of months back, so feel free to check that video out. I think it's advisable for you to go through that video or at least attempt that question first before you uh, try to attempt this question because that question sort of like gives like a foundational understanding in terms of how to solve this question. The pattern is similar in terms of how we're going to solve this question and the part one of this question, but this one has a little bit of twist. But in general, once you recognize the pattern in terms of solving valid palindrome, is pretty much the same between the part one and part two. So basically, the only difference between part one and part two is basically in this question we are allowed to delete at least at most one character, and upon deleting that character, we have to identify whether that new string is basically a palindrome or not, right? So let's take a look at these two examples here. ABA basically is a palindrome, right? So just to recap, in case for those who do not understand what is palindrome, basically if we spell string or a word forward and backward, it is exactly the same, right? So basically if we spell from forward to backward, ABA, and if we spell it backward to forward, is ABA, right? So both ways are both direction is the same, so this S string here is a valid palindrome. So let's take a look at example 2. We have ABCA, right? So if we spell it forward, it'll be ABCA. If we spell it backward, it's ACBA. So this is not a valid palindrome. But if we delete the character C, this C is taken out, then basically we are left with ABA, kind of like the first example here. So as we have seen in example 1, ABA is a valid palindrome, right? Spelling it forward and backward gives us the same string order, right? So in this question, we are asked that if we can delete at most one character, will the new string be a valid palindrome? And the answer for this example 2 is yes, right? Because once we delete C, that puts us to deleting one character, so we have hit the max limit, and then the new string is ABA, and hence that is a valid palindrome, right? So pretty much that's it. I think these two examples sort of like give us a good insight on how we're going to solve this. So I'm just going to code it out and I'll explain as I go. So I'm going to do a quick check here. If S is empty, basically I'll just return true because empty string forward and backward is still an empty string. So I will just consider that as a valid palindrome. And I'm just going to convert the string into characters, so I'm going to use the array. So this just transforms all the string into a character type, and as we've seen in valid palindrome 1, we're going to do a two-pointer approach. So just keep this in the back of your head whenever you try and tackle palindrome question. Two-pointer approach is really handy, so just try and keep that in the back of your mind whenever you see a palindrome question. So I'm going to do a starting pointer and ending pointer, which is count -1 because we are dealing with index base. So yeah, so that's why we -1. And then here what we're going to do is do a while loop or start into end, right? And then I'll just return true here. Okay, so basically what we want to do here is if array s of start is not equals to array s of n, right? So whenever we find an anomaly, then we have to do something, right? In this situation here, in this example 2, we have an anomaly, right? Which is a and a is the same, so that's good. So then the second loop, where we increment start and decrement end, b and c is not the same. Now we have to make a choice here where if we remove at most one character, can the new string be a palindrome, right? So before we do that, I'm just going to make sure I increment the start and decrement the end before I forget. So in every while loop iteration here, we are incrementing the start and decrementing the end. So it's two pointers going towards the middle of the string, right? So for us to check this here, I'm just going to create a separate function. I'm just going to call it check, and then I'm going to call it cars, expecting an array of characters. I'm going to create a starting pointer here of type in and end int. Because they're not in out, this is basically a constant, we can't manipulate it, so I just need to create that as a variable, and then variable n equals to n as well. And then here what we're going to do is sort of the part 1 solution, right? This is where we actually check whether it's still a valid palindrome as well. It's kind of similar to this one here. So start is less than n if cars start not equals to cars n, basically we just return false, because that means this is not a valid palindrome, right? They're supposed to be the same. Start end. So same thing, incrementing the starting pointer and decrementing the end. Otherwise, if it does not get caught here, that means we have checked this string and it is a valid palindrome, right? So this function here represents the condition when we have dropped a character. So how do we do that? Basically here, I'm just going to return check and then pass in the array s, which is the characters, and then here I'm just going to increment start, which means I skip one letter, and then I'll keep the end the same. Or because we are only allowed to delete at most one character, so I'm just going to do the same thing here, but the difference here is keep the start the same, but I'm going to decrement the end. So this is an OR operator here, and then the first part is basically in this example here is sort of like checking whether if you skip B, is it still okay? And here is like if you skip C, will it still be okay? And then it will just call this function here, and then this is where we already passed in the characters where we have skipped. Basically this one will have to expect that every character from the starting pointer and ending pointer converging towards the middle should be the same to ensure that it is a valid palindrome. So I think that's pretty much it. I'm just going to try and run this code, and hopefully we got it right in the first try. No, we do not. Cannot convert. Alright, so let me just return bool here. Try and see that's true. Let's try and see this. There we go. That is the solution for this question here. I just forget the return function statement here, but otherwise the logic is pretty much the same. So just to recap on how we tackle this problem, we are doing a two-pointer approach, starting pointer and ending pointer. And in this question, basically we are just finding in the while loop if there's any anomaly. If there isn't any anomaly, we just continue incrementing start and decrementing end and just check whether all the characters are the same. If it is, basically we'll just return true. If it's not, if we discover there's an anomaly, basically we are going to skip the character by incrementing starting pointer by 1 and decrementing ending pointer by 1. Uh, and then in this helper function here is basically doing the same thing as with the palindrome to validate it whether each character in the while loop is the same. If it's not the same, then we know for sure it's no longer a valid palindrome because we have deleted at most one character from this line here. So yeah, I hope that's helpful. If you do, please feel free to subscribe to this channel. I'm trying to grow this channel and I would appreciate your help. So yeah, thanks for your time. Take care and bye bye.